I am Dr. Untitled, Professor of Civil Engineering Department, SUIT, Bangalore. Let us see the continuation of the Module 3, Bending Moment and Shear Force. In this, we will see today the relation between load intensity, shear force and bending moment the relation between load intensity, shear force and bending moment. Let us consider a beam loaded as shown below. I will write the figure. Let us consider a beam loaded as shown in figure below, as shown in the figure. Now first we will draw one sketch beam. This is the beam. See, here both ends are simply supported and it is acted upon by a uniformly distributed load. It is W per meter length. Again, the span of the beam is L. Let us take a small portion of this beam for deriving the relations. This section is 1, this section is 2, and this distance between the two sections is dx. Again, this section is a distance of x from support A. Now what I am doing is I am taking enlarged figure is of this smaller portion dx. I am writing here this dx portion to the enlarged figure. See, this is the dx portion, enlarged figure. This is section 1 and that is section 2. This is section 1. This is section 2. Section 1 and section 2. Here the shear force is acting, one shear force is acting at this section upward, and at a distance of dx, the shear force is acting downward to the right. It is F plus df. Similarly, the moment at section 1 is, here it is F. The shear force is F. M. At section 2, it is acting in anti-clockwise direction. This is at a distance of dx little more. It is how much? M plus dm. See, here moment M means after certain small distance it is addition is M plus dm. Shear force is here F means after certain distance the addition is df. Therefore F plus df. Therefore the distance is dx. Now let F equals shear force at section 1. Shear force at section 1 F plus df equal to shear force at section 2 to shear force at section 2 to M equals bending moment at section 1 bending moment at section 1 M plus dm equal to bending moment at section 2 to bending moment at section 2 to. Now what I am doing is resolving the forces of the elements considered. Now resolving the forces considered in the element first we will take summation of all the vertical forces should be equal to 0, that is sigma v equal to 0, treating upward forces positive, downward forces negative. Now F force is, this is the F force is upward, therefore it is plus. Then here UDL is there, we take this UDL also because here UDL is there, this UDL is W per meter, this UDL is acting downward, the total intensity of UDL is W into dx, it is acting downward, therefore minus W into dx minus this shear force is acting downward, F plus df. During sigma v equal to 0 and sigma h equal to 0, these moments are not taken into consideration. In the summation of the vertical forces equal to 0, we will take that equation. These moments are not taken into consideration. From this minus f, this plus f get cancelled, minus f plus f get cancelled. What is remaining now? Here minus df equal to, you take this to the right side, w into dx, or df by dx equals minus w. df by dx equals minus w. The above equation shows that the rate of change of shear force is equal to loading. See, the shear force, if you rate of change of the shear force, it should be equal to the load. If you differentiate this with respect to shear force with respect to x, you are getting the load. The above equation shows that the rate of change of shear force, the rate of change of shear force is equal to loading. Now we will take the moment. Now we will take moment of all the forces about section 2 to. Now let us take moment of all the forces about section 2 to, Here you see here this moment equation, I am taking the moment of forces about this section to this point. Therefore this m is positive, then we will take this as positive only for the moment, not necessary to multiply with any distance. Again, the moment due to this F force about this section is clockwise, F into dx, therefore plus F into dx. Next, the moment of this force F plus df is about this point is 0 because that force is acting at the same point. But moment due to this UDL is downward, it will create anti-clockwise, W into dx by 2. it is minus w into dx into dx by 2. Again, moment due to the shear force F plus dF is 0 because that force is acting at the same point, minus m plus dm. Minus m plus dm. Moment we have to take, that should be equal to 0. That should be equal to 0. Now this plus m minus m get cancels. What is remaining? F into dx minus w into dx square by 2. W into dx square by 2. Next one, minus dm is there. If you take to the right, it is plus dm. Therefore, I am really considering, see, the dx is very small. Again, the dx square, it is negligible. For example, 0.02 into 0.02 is 0.00 something. It is neglected. Therefore, this value, because of it is very small value, we are neglecting this, making it 0. Neglecting the higher term, neglecting the higher power terms, higher power terms, that is w into dx square by 2 equal to 0. Then what is remaining now? F dx equal to dm, or we can write this equation F equals dm by dx. From this it is clearly you know that the rate of change of moment is equal to shear force. Rate of change of moment equal to shear force. From the above equation we can see that the rate of change of moment is equal to the shear force. Equal to the shear force. Now we shown that the rate of change of shear force is the load. Again, rate of change of moment is the shear force. Rate of change of moment is the shear force. There is a connection between, there is a relation between load, shear force and bending moment. We proved this. Now let us see some sign conventions before solving the some problems. Sign note. This is the note. Sign conventions. Sign convention. First one is sigma v equal to 0. That is summation of all the vertical forces equal to 0. Taking upward forces positive, downward forces negative. Second sign convention is sigma h equal to 0. Rightward forces we will take it as positive, leftward forces we will take it as negative. Next, third sign convention is sigma m equal to 0. Sigma m equal to 0, treating clockwise moments are positive, anti-clockwise moments are negative. Fourth one is for shear force. For shear force, for example, this is the section line. This is the section line. You can take on the beam. To the left, upward forces we will take positive, downward forces we will take negative. If you consider right portion, upward forces we will take negative, downward forces we will take it as positive. The last sign convention what we followed, it is for bending moment. For bending moment. Bending moment. Again, for the bending moment, this is the section line means. This is the section line means. To the left, clockwise moments positive, anti-clockwise moments negative. To the right, clockwise moments are negative, anti-clockwise moments are positive. Anti-clockwise moments are positive. These are the some sign conventions. These are the some sign conventions we followed for solving the problems in this module. 3 shear force and bending moment.